Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the winding resistance test in a transformer. So normally, the winding resistance test is an important diagnostic tool for assessing the possible damage to the transformer resulting for a poor designs or assembly or handling, which means shifting of transformer from one place to another place, and also unfavorable environmental conditions and overloading or a poor maintenance. So the main purpose of this test is to check for a gross difference between the winding, which means in a open in the condition, are changed due to the short turns or loose connections inside the converter transformer or a power transformer or distribution transformer. Then transformer winding resistance measurement are obtained by passing a known DC current, which means the DC current of 1 amps, 10 amps or maximum 25 amps. It's depending upon the load factor or the winding inside the transformer. So by injecting the DC current, we are going to measure the voltage drop, in which the resulting resistance of in a milliohms or microohms value. So it is done by each taps of a transformer. The transformer tapping may be a on load tap changer or off load tap changer, whatever it may be. For each and every taps, we are going to measure the winding resistance test. So this is the temperature correction for the winding resistance test. Temperature correction is a winding resistance depending on the temperature. So the temperature correction also we will done for a 75 degree or 80 degree, up to 85 degree. Then the measurement resistance should be corrected to a common temperature, which means the in factory designed it will be a common temperature as a 75 degree or a 80 or 85 degree, neither less of our ambient temperature. So we are going with this formula. RC is equal to RM into CF plus CT divided by CF plus WT. Here RM is the measured resistance which we are measuring in the ambient temperature. Then CF is the corrective factor, which means 235 for copper, 225 for aluminum. Then CT is the corrective temperature, which means 75 degree or 80 degree or 85 degree, whichever we are using, that's the corrective temperature. Then same CF, then plus WT is your winding temperature at the time of test. So this is the formula for the correction of a temperature. Normally we will get one winding resistance value after injecting the after injecting the DC current, we will get a voltage drop. In that we will get a resistance, which means the measured resistance at the ambient temperature. So this ambient temperature resistance is converted into a corrective temperature according with the factory defined values at 75 degrees Celsius or 80 degrees Celsius or 85 degrees Celsius. So this is the formula. As you know that for injecting the DC current, there may be a chances of magnetizing the coils inside the transformer. So we have to do the demagnetization after completing the test of DC induction winding resistance. So this is your primary winding, this is your secondary winding, this is your core part of our transformer. So as you know that we are going to inject a positive and negative, which means a DC voltage through the primary side of your transformer, and we will get the secondary side. Likewise, we are going to inject a DC voltage and demagnetize the transformer. So in nowadays this demagnetization was not happening because in the kit itself we are having the demagnetization option. So as our concern or as our checkingness, healthiness checking, we are doing this demagnetization physically by ourselves, manually by ourselves. So demagnetization is done after completing the test for a smooth operation of a transformer. Demagnetizing the transformer removes the residual magnetizing flux, which means the circulating flux inside the core element, caused by passing a polarized DC current through a winding during a resistance test, which means the DC current which we are using for a resistance measurement, that which causes a residual magnetizing flux, which means the circulating flux inside the core, that is to be removed by uh, giving a DC pulse through the primary side of your winding, and then earthing through the secondary side of your winding. So this demonetization should be done after completing the test. If it is not done, means the excess of a residual flux in the transformer core may carry a large inrush current and could trip the protective relays. So demagnetizing is done by passing a multiple cycle of a reduced current through a winding in both positive and negative direction. So it is only need to be polarized in a single winding only after completing the test. So this is your kit connection. The winding resistance kit comprises of a two current cable and two voltage cable, which means one positive negative current cable, one positive negative voltage cable. Here the positive, both the positive of current and voltage are connected in the one end of our winding, which means in the primary end. For a single phase transformer I am telling, in a second in a primary end, and negative side is connected in the secondary neutral side of your transformer. After connecting this, we have to inject a DC current, and then we will measure the resistance through the voltage drop inside the transformer. So this is done after connecting like this. It will be done for each taps of our transformer, and then after removing this for a nominal taps, only for a nominal tap we will do in a secondary winding, which means for only one tap we will do in the secondary winding of our transformer for a single phase transformer. And for a three phase transformer, same wise, in each phase wise we will connect the transformer, or between the phases we will connect the kit, and we will check the measured resistance inside the transformer. So it is connected by a positive terminal on both current and voltage on one winding, then negative terminal of both current and voltage on the other end. For injecting DC current and measuring voltage drop, the resistance is measured. Then note voltage load inside the current load cable. And this is a small information that the current lead will be in the outside the connection, and voltage lead will be inside the connection. While connecting both of the terminal at the same end, the current lead will be in the outside and voltage lead will be inside the connections. So this is the winding resistance of a transformer for a three phase and a single phase are same wise it will be happening. So see you in the next video. Nandri, vanakkam.